Innovations, and the Young AFCEAN Vice President as well, the industry lead. He currently works for SRC Technology, where he oversees the technology and invocations team. Brandon has supported the intelligence community for nearly 10 years. Ladies and gentlemen, Brandon Lester.
Thanks, Gina. Welcome to the panel. I thank everyone for coming, and I want to start with a few overarching thank yous, and then we'll jump into some introductions for our panelists and go right into questions. So thank you again for attending. So first and foremost, I'd like to thank AFCEA International for hosting TechNet jointly with us here in the Hawaii chapter. I'd like to thank the Hawaii chapter for allowing YACS to host a panel, especially given we get to take everything from soup to nuts, and I get to appoint myself as moderator. I'd also like to thank all of these panelists. I feel very, very privileged to have a distinguished set of guests that are all very, very good technologists, and I think we'll have a lot of good things to say. I'd also like to take a chance to do a second plug for Young AFCEA, as Gina mentioned. We're really looking forward to taking the Hawaii chapter's Young AFCEANs and taking things to the next level, striving to be the next generation to lead the chapter, but also develop young leaders here in Hawaii. Beyond that, I'd like to jump into some introductions. Here on my left, your right, is Mr. Mike Henry. He is a lead data scientist for the MITRE Corporation, and he works in a multitude of government sectors to include national security, transportation, aviation, and commercial space operations. His aviation safety research has been operationally implemented on a national level at some of the nation's busiest airports. The research has also been internationally recognized as a recipient of the 2015 IHS Janes ATC Award, and his current research focuses on integrating analysis with national security datasets, provide predictive capabilities that integrate with operational solutions for the PACAF. Mr. Henry holds degrees from Virginia Commonwealth University and the University of Virginia. On his left is Mr. Vince Lee. As a senior solutions architect, Vince Lee is passionate about technology advances in networking and information security. With a technical career that has spanned the globe, his focus has been on the Indo-Asia Pacific region for over 20 years. Vince has worked for Fortune 500 companies in the networking and information security space, and he has a unique perspective when solving problems based on his ability to understand vendor and consulting perspectives. He shares his passion for technology with the next generation of networking and security professionals as an assistant professor at Leeward Community College here on Oahu, and he enjoys volunteering to work with the community. Vince has assisted with public cybersecurity events and taught seniors about cybersecurity best practices to keep their information safe as an ISC Squared Speaker Bureau volunteer. He's also a practice speaker and has presented at many events around the world, including numerous AFCEA events throughout his career. He's a proud graduate of University of Hawaii Manoa with a master's degree in both information and computer science and mathematics. On Vince's left, we have Dr. Robert Renzer. Dr. Renzer is the technical director at NSA Hawaii. He oversees the technical execution of NSA Hawaii's signals, intelligence, and cybersecurity missions in support of national customers, including U.S. Indo-Pacific Command. As part of NSA Hawaii's technical outreach team, he's led development of partnerships with local academic and industry organizations to advance operational capabilities, promote cybersecurity best practices, and recruit local talent to NSA's missions. He's represented NSA Hawaii at local events in Hawaii, such as the annual Future Focus Forum, other AFCEA conferences, and the Hawaii International Conference on System Sciences. From 2006 to 2015, Dr. Renzer held positions at NSA's Research and Signals Intelligence Directorates, where he focused on developing capabilities for cyber network operations and cybersecurity defensive measures. He's assisted federal partners to improve the security of national telecoms communications and briefed numerous leadership bodies, including the White House, National Security Staff, congressional staffers, and other intelligence community agencies. He's received NSA's Meritorious Civilian Service Award and the Distinguished Presidential Rank Award. Prior to joining NSA, Dr. Renzer was a senior research scientist with the Applied Research Division of Telcordia Technologies. He led the development of several research projects funded by federal agencies to explore advanced in optical communications, quantum key distribution systems, and photonic signal processing. And last but certainly not least, we have Mr. Chuck Weissenborn. Chuck serves as the Senior Director of Symantec, where he supports the Army and its warfighters globally with best-in-class cybersecurity solutions. Prior to joining Symantec, Chuck served as an active Guard Reserve soldier supporting Texas Army National Guard. And as an AGR soldier, Chuck served in various duty positions, including Battalion Operations, NCOIC, and Signal Company First Sergeant. He currently serves as a Senior Incident Responder in the 136th ESB and as a member of the Texas Cyber Operations Element as a traditional guardsman. Chuck holds several industry standard IT security certifications, and he is active in the San Antonio community and is the Vice President of Young AFCEA for the Alamo chapter of AFCEA. He's also an active member of the Signal Corps Regimental Association and the Military Cyber Professionals Association. He's the recipient of the Bronze Star Medal and the Combat Infantryman Badge, as well as a holder of the SCRA Bronze Order of Mercury. So with that as a series of introductions of our panelists, I'd like to jump into the topic, but give a little bit of background on some common denominators. So what we're attempting to answer here is data and what's changing and how it's going to take us into the future. So the title of the panel as how data is changing our world using big data analytics and cloud computing does not necessarily tie all those things together into one finite answer or problem set. But I wanted to lay some groundwork so that we can establish a series of questions. So first and foremost, I think everybody in the room can certainly agree that data is pretty much everywhere, and more than you even realize. Your phone, your social media profile, your credit card buying power. I was at a talk not that long ago where the VP of Big Data for MasterCard said that he thinks he can predict a divorce 3 months before it happens. And that is literally based on purchases from a credit card. Beyond that, everything that we're all here to accomplish, whether that's mission or information assurance, the use of this data has really, really exploded, and that goes on any number of fronts. But the name of the game, no matter where you are or what you're doing or what you're working on, is going to be data. So leading into new and interesting ways for utilizing this data is one of the main points that I'd like to highlight, especially given that there are opportunities to disrupt and essentially change the way that we do work today. So a few different specific definitions I'd like to jump into, and these are going to be very high level. From a cloud computing perspective, the transition from on-premise or in-house data centers moving out to something in a cloud-hosted environment, could be on-site, could be off-site, but basically breaking away from what we all used to think of as the physical installment of a server. Nowadays, a lot of these services are offered as infrastructure as a service, platform as a service, or software as a service. And we may or may not touch on some of those topics, but the main highlight there is that we're essentially giving folks the opportunity to build on platforms in which they don't have to own some of the problems that came with physical hardware. From a big data perspective, in the simplest sense, it's when you have too much data to run on any single machine. So when we talk about big data problems, big data analytics, we're really looking at size and scope of data that we get nowadays that really takes us into a distributed computing solution. And then finally, analytics. I'm going to read the copy and paste from Wikipedia because I was pretty satisfied with that one this time. The discovery, interpretation, and communication of meaningful patterns in data and applying those patterns towards effective decision making. Analytics transcend specific topics or specialization, and they're used everywhere from business to cybersecurity to advertisement. So without further ado, we will have some questions from anyone that sends them in, answered at the end. But for now, I'd like to jump into the first question that I have for the panel, and I'm going to offer whoever's is the most excited to answer, and we'll go from there. So first, cloud infrastructure, data science, and big data analytics are at the core of modern technology. What technologies have you, your organizations, implemented that you have become the most excited about?
So I guess I'll grab that one because to me this is some cool nerd stuff, right? So I come from an operational background. I started out as an infantry guy at the short end of the stick. So when I look at technology, I look at how it can actually be used by the warfighter and how it can make people's lives easier and how we can kind of crunch the stuff and find things that we wouldn't normally be able to see without hours and hours and hours of work. So Symantec is the world leader in cybersecurity machine learning research right now. We hold over 2,000 patents. We have two major centers of machine learning and AI research, the Center for Advanced Machine Learning and Symantec's Research Lab. And what we're able to do now, using our global intelligence network, which consists of data feeds from all of our products worldwide, is we're able to go into our data lake, which today I think consists of around 3 trillion log lines of data, of which 100 billion data points are being added to daily, and find low incidence threat actors. So good example, we found an actor that was targeting PACOM region where there were 5 blips over the course of a 1.5 year period. We're able to do that with about a 99.07% accuracy rating, which is pretty impressive when you're talking about dealing with that much of a data set. So that's taking all the work that we've been doing over decades and going from a single algorithm to a multi-algorithm to a multi-algorithm training model to make that stuff effective. It's really excited to be able to do that and then provide that feedback back to the customers in the form of our threat feeds to the products, so that everybody's getting real-time feedback as we learn what's going on out in the world. We're also working on a product called Targeted Attack Analytics, where we're having our AI algorithms trained by our threat hunters almost over the shoulder. So they're riding along with our analysts as they go throughout their job on a daily basis and learn what those guys do to make the algorithm itself more effective. And then finally, we're going into and starting to look at distributed machine learning, where we're taking this problem set that's in a huge data lake now and trying to push the analytics down to an individual's customer environment. So within the Army concept, that could be all the way down to the far tactical edge, lower tactical internet brigade and battalion, and putting the analytics on board at those levels so that each environment gets an algorithm that's tuned itself to that specific environment. And then by rolling those things up where it's appropriate and where you have bandwidth, making that much stronger of a global intelligent algorithm for that organization. So that's pretty awesome stuff from a cyber perspective. Being able to go into an environment and save somebody hours upon hours of work, freeing them up to do more work cycles, educating their command, and actually doing the soldier stuff that they need to be focused on as well as the cyber mission. Thanks.
So I guess I'll jump in here as well. So NSA has been undergoing a transformation to the cloud for over a decade. And what I'm really excited about is when we look at our targets do not tell us directly what their intentions are and what their plans for the future are, but that's exactly what our customers are asking NSA and the intelligence community to provide to them. And so we have to look at the reflections of target behavior in our signals intelligence apertures to kind of glean what are our target's intentions, where are they going, and we get partial bits and pieces of that information, whether it's through ELINT, electronics intelligence, or comment, communications intelligence, right, or cyber, right? That's a big part of what NSA does now. What the cloud enables us to do is to get that data out of the traditional database stovepipes and into one place so that our signals intelligence analysts can look across all domains and try to glean that target behavior rather than narrowly focus in just one. And of course, what we're finding is the correlations across those domains are yielding insights that were never possible before. So you look at a combination of geolocations, some communications, and some cyber activity, and then suddenly you can actually see a much broader perspective of the target and their behavior and their plans and their capabilities that was just not even conceivable before when those segments of data were siloed, and those analysts worked exclusively within those silos. So the cloud really enables the aggregation of all of that information. Of the technologies, though, for the future that I'm really excited about, now that we've gotten most of our data into the cloud, is data science. And I'll talk less about the technology and more about the people, because it's really going to be the people, the data scientists themselves, who are developing those new analytics to enable greater insights into the unknown unknowns, the anomalies that truly are early indicators and warnings of new target capabilities or behaviors. Those are the things that are going to propel our intelligence for the future. And so it's not enough to just plop an algorithm, from open source onto our data and then trust the answer. We need data scientists to curate that data, to train those algorithms, to understand the right and left limits and continue to refine them while they push that out to the frontline analysts who are doing the reporting. So in terms of the resource I'm most excited about looking forward for the next 5 to 10 years, it's really recruiting the top data scientists to help us create algorithms to now unleash the true power of the cloud and of all the data we've collected against the target. That's really going to be, I think, the game changer, but it's not going to happen with technology alone. It's got to come with the people to implement that technology on our exclusive data sets.
Oh, excellent. Okay. Am I live? Can you hear me? Here we go. So over the last 15 years of working analytic projects, we've really gone through a renaissance with big data analytics. And it's actually, the way I see it, it's a simple case. We now have the ability to commonly bring together our analytic analyses and outcomes to share with the entire community of analysts at a given organization and or partner organizations in a common framework. It used to be that we did a lot of projects in C, or students would come out of school knowing MATLAB, and they'd bring MATLAB to the table, and they would go off and they'd hide in their office and do some real just wild science stuff and spend a lot of time working on their little project that nobody else got to see except for a PowerPoint briefing. Really, the collaborative environment that we've created through data analytics and applying that into various common languages has really created an exponential velocity of the ability to create insights into our operations from day to day, to a holistic picture of how a specific operation is doing from the business sense, from the safety sense, and where investments should be made. We've definitely seen that at MITRE through aviation research, intelligence research, and trying to create insights for the DoD. And in fact, when I started the large project that I was working on last, I started with a third order derivative data set that other people had already started to really, really work on. So the nice thing is that we had over 20 analysts looking at the exact same data set and refining that through quality assurance, and then retooling that analytic diagram such that we can do the directed analytic graph in a very, very refined way. And so being able to do that, I had other people looking at problem sets that I didn't have time to look at. So one of the big issues that we found is that we found that there's timing errors. So we were in a kilohertz data set, and we found out that there were leap seconds among it and differences between UTC and Linux epoch. So we were pulling data off of radars and finding out that there were these small accelerations that previously we didn't notice because we were dealing with 1 second data, and then we started looking at a safety case for the Falcon 9 flyback booster, and we were at millisecond data, and we were finding accelerations in energy there that clearly were not present during the rocket launch. So we then retooled our aviation data set against what we were looking at from the rocket telemetry data. So being able to do that would have previously been 3 or 4 different projects, and they all would not have talked, and they might have even had conflicting result. So now we have this common analytic framework, and I know that it's not necessarily the technology itself, but it's that we were able to bring together a common analytic community under one platform.
So my focus is going to be a little bit different. It's going to be more on the connectivity side. And the reason why I'm saying that is because of the fact that we have a physics problem. right? How do we transmit all this data to the cloud from your locations and disparate locations? So early in my career, I had the great fortune of working for a company that was the forefront of moving towards gigabit and 10 gigabit Ethernet. And I was capable, or given the, I guess, problem set of solving a 320 gigabit router at wire speed, right? That is a massive amount of data at that time. But you think about today's world, the amount of information that's flying around. They just announced a spiral optical capability of doing 2.6 terabits per second, which is phenomenal. If we can get that kind of scaling, then the move to the cloud will be easy because we'll have that capacity. But the back end of that is, do we want to put all that data out there, right? There are certain things we don't want to put there. And what's been very, very, an area that I've been really interested in is the really focused area on containerization, right? Getting rid of the operating system. And by doing that, we've lightened the load and we've created an environment that can scale massively very, very rapidly. So that's kind of my focus area in this. That's what's getting me really excited.
Thank you. And forgive me, I'm going to add a few interjection points. I'd like to kind of tie all that together. We've got an Army perspective, a forward battle consideration where you need data on the edge. We jumped all the way to cloud computing from an NSA target perspective and rocket launches, right? All those things together could be considered each their own crazy topic, but bringing those into a data analysis perspective really, you can see that this is a wide-ranging set of interests and topics to pretty much anybody. So jumping into the next question, cloud computing, DevOps, and other new themes and technology really allow us to rethink how we've approached our infrastructure. Going from the cloud transitions that began years ago, how much cloud computing do you think your organizations will be using in 1 year and 5 years?
So I guess what I'm going to do with this question, I'm not going to talk specifically about how much cloud computing NSA has. I can't add that in this forum. Suffice it to say, the goal is to get all of our data that's non-real time into the cloud. We'll talk maybe later about real-time analytics and streaming architectures for that real-time component. But the part of the question that most resonated with me when you asked it was, how did the transition to the cloud cause us to rethink our data model? And what the cloud allowed us to do is to rethink how we secure our data. We've learned, like many large enterprises, sometimes the hard way, that if you allow system administrators to have back-end access to your data, right, you have to inherently trust what they do. And we've unfortunately had our own experiences with public disclosures of information that should not have leaked out of NSA. And so with the transition to the cloud, what we've implemented is a new security framework for securing the data at rest, the data in motion, how the data is administered, as well as how the data is queried. So a given analyst who's working in cybersecurity can't also query data from another part of the mission unless they have entitlements, the authority, and the authenticated PKI access. So it's a multi-layer security model. All the layers have to interact. All the layers have to be updated in real time. So if somebody's credentials get pulled or someone changes their mission, it's nearly instantaneous that access is lost and whatever the new access is that they need for the mission is gained. And we have auditors who are looking at all the logs, both at machine speed as well as some manual curation of those logs to look for anomalous behavior. So a lot of effort went into the data tagging of all the data that was coming into the cloud or perhaps re-ingested from our old data sources that did not include these entitlements. And that has also made it, by the way, difficult to take commercial solutions into NSA's cloud environment because of some of the proprietary ways that we have implemented our security model. But what I can tell you is we feel very confident that this is the wave of the future and that many organizations that have had breaches of large scale from data stored in the cloud, those breaches would have been contained or perhaps even headed off or prevented in the first place if some of these procedures were followed. So we really viewed the transition to the cloud as a new opportunity to rethink security for the 21st century. And so every element of data that's touched at NSA, we know who touched it, we know when they touched it, and we knew whether or not they were authorized to touch it. And that's really got to be the model, I think, for any sensitive information that's stored in the cloud, whether it's commercial or government. And so we really took security extremely seriously when we transitioned to the cloud. And I won't say that we're perfect, but I will say we put a lot of thought into this, and we feel pretty confident that this is an important step into the future for other government and perhaps even for commercial industry struggling with how to make sure security and data tagging and things like that are done properly.
Do you mind if I ask you a follow-up question? How do you ensure that analysts are provided an immersive data catalog to know that they need to apply to be able to access a specific data set in order to gain analytic insight? Given that sort of security architecture, what we do at MITRE is we trust the analysts with the intellectual property and that we are good stewards of the government's data set. And given that you're an analyst, you do your due diligence to do no harm with your statistics. So at the NSA, how do you approach having that environment where analysts are able to dig into data they didn't necessarily knew existed to solve their analytic question?
Yeah, so one of the things that our data scientists do is they actually serve our target office of primary interest. So the data scientists don't go exploring without knowing that they're meeting an intelligence requirement. And so everything begins with an intelligence need from a customer. That's actually one thing. We're not authorized to go beyond the scope of our customer's requirements. So that's the first boundary that we have to respect, and that's by policy. So we have to stay within that scope. But within that scope, a customer can say, look, I'm interested in understanding the correlation between geolocations, signals intelligence collection, and this comment selector, and we want to bring all that together. And they will authorize the data scientist for the period of the project the ability to aggregate that information. As they pull that data in, it's all audited and logged that they have that information, and usually it's on an expendable platform that disappears within 30 or 90 days. So it's supposed to be disposable. They don't get to store the data indefinitely. If they do, they have to either apply for a compliance waiver or re-ingest it. And so all of this is audited and logged, but it does still allow the data scientist some freedom of movement. However, it has to be directed by a customer. It can't be the data scientist the data scientist can ask the customer, hey, I think if you have other data in this area, in this domain, that would help. But it's really driven by that customer requirement. And I think that's why it's important to make sure our customers are educated about the promise of data science so they can ask the right questions. But it has to be authorized by that customer-data scientist relationship.
Thank you.
So Symantec, from a cloud perspective, is all in. A couple of years ago, Symantec said, hey, we're spending a lot on infrastructure dollars. We're spending a lot on maintenance and the personnel costs, the total cost of ownership of hardware, as everybody knows, is super expensive. And we migrated the entire company to the cloud. There's still some legacy pieces here and there, but I would say that today we're probably about 95% cloud-based. And real dollars saved is probably over $100 million total within the past 2.5, 3 years. So huge savings from what we were experiencing. I mean, just astronomical from a corporate perspective. From a military and DoD perspective, though, what is the cloud, right? Yeah, that's one of the fundamental questions that, depending on who you ask, it's different. So, most people think it's a collection of computers somewhere else. Well, if I'm a telco provider and I'm getting information from your phone, that's the cloud to me because it's all distributed, right? So when we're having these conversations about are we all in, I think the interesting perspective is to say, okay, do we really know what the cloud is and how we can kind of leverage all this distributed space, within the environment? You made some excellent points from a security perspective too. How do we get visibility? I mean, today, if you look out there, I think there's probably 135,000 cloud applications, something ridiculous. How do we, as custodians of data and managers of environments, actually get visibility to what's going on when we don't even understand what the cloud applications are that may or may not be present in the environment? So those are some of the interesting challenges, I think, when we talk, are we in the cloud? And the answer is yes. And there's nothing we can prevent anybody from being in the cloud at this point in time. It's just something that we kind of have to expand this conversation. And when we talk about data protection, for a while, we keep hearing that we're going to a data-focused protection model, right? How many people have actually seen a data protection strategy within their workspace? I mean, our company has one, but within a lot of the other areas they go in and operate, there's not. And I think that's a fundamental issue where we've got to look at and got to, as cybersecurity professionals, help our policymakers understand, where we need to focus on what that actually means. And in order to do that, we've got to understand where the data is and, what our cloud is.
I'll add to that. So as my role as a consultant, I get to get a cross-section of industries, right? Financial, educational, state and local government, as well as the Department of Defense. And everyone has an initiative to move to the cloud. And it's familiar, right? Everyone uses email on their phone. But the threat vectors are much more enhanced by doing that naturally because it's out of your control. It's not within your space. It's your shadow ITs, all of the areas that you didn't have to deal with before when it was on your premise. So you see some people tipping their toes into cloud by saying, I'll have a hybrid cloud. I'll have something on my site and I'll have something remote. Maybe it's my backups of my data, et cetera. And they're going to transition to it slowly until they resolve these issues. But I think you made a great comment about the stovepipe systems. There's so many systems out there that are one-offs or uniques to those organizations. And to lift and shift that to the cloud will take an enormous amount of time and an enormous amount of development. It may not be suitable. They may have to move to another commercial application simply because they don't have the resources to actually take this application there. And with that in mind, you're now going to have kind of a splintered organization for a while until they reorganize their policies and the procedures to accommodate these new applications that are sitting out there. So I would say right now, in many cases, you have organizations embracing hybrid cloud, maybe private cloud in certain situations, and then when they can, move to a full cloud solution. But even at that point, they're still going to be concerned about where is my data, who is protecting it, and how do I recover it? A classic example is if Rackspace went out of business today, what would happen to all that data? Could you get it back, right? Are you the owners of that data anymore? Same thing with Amazon, right? AWS and Azure. So these are really good thought processes that have to be looked at for the long run if this organization is going to hold you hostage if you want to extract your data.
So I'd actually expand on that just a little bit. From a corporate perspective, I think those of us that manage enterprise environments, it's a little bit easier when we look at cloud because we have a very good idea of what our utilization looks like. And most companies, unless you're in a company that has a high DevOps environment, and that's, to a certain extent predictable as well based on work cycles, know what that's going to look like. But I think one of the issues that we have within the DoD, and something that we should all carry back to our commanders and up to our channels, is the fact that the billing cycles that we're looking at from the various environments don't lend itself to predictability. And because we have this budgetary issue where we can't predict what that bill's going to be for utilization at the end of the day to whatever cloud service provider it is, be it Azure, MilCloud, DISA, who have you, it makes it a very, moving to the cloud becomes very cautionary. And, if I can't predict what my budget's going to be, if I can't predict what my pop-up targets are going to be, I can't identify total cost of ownership, and therefore I'm not going to move because what I have right now is predictable. And I can at least put hard numbers against that. So that's something I think we all need to be cognizant about as we're having these discussions is, from a financial perspective, I think that's why people are sometimes reticent, especially on the DoD side, is because we just don't know what the money looks like.
Chuck, I fully agree with you. At MITRE, the clusters I've been working on, they are all physical hardware, and they go up to about 2,200 data nodes. They're heavily optimized against the data set that we own and the questions that we're trying to ask relative to the type of algorithms that we're trying to build and develop. So that also includes GPU clusters and CUDA that we burst compute for various matrice operations that need to be exceedingly fast because of the expense of the operation. With that being said, we are a heavy cloud user in that we do burst recompute of our data set as we find bugs. There are tons of bugs in data analytics, and you will continue to find bugs as time goes on. And since big data constructs like Java MapReduce and the Hadoop file system is a write once, read many, you can't afford to continuously lean on your physical hardware to do back compute, considering that we have anywhere from 80 to 100 analysts at a time running jobs on the cluster. So to be able to go back and do prod run for back compute because you found a bug in the data, it's not really practicable. So what we do is we trust a cloud provider to do that. With that being said, it's been quite difficult for us to figure out how to get that job done. And during the negotiation of it, there was actually a point in time where we were considering a very real contingency of putting a SAN array into a box truck and driving it to one of the company's locations because we had something like 2.9 petabytes worth of data to move in order to do that back compute. So cloud provisioning and being able to build out a cluster in the cloud and create the derivative data sets to get your version plugged based upon finding bugs and various other things, or holes in the data that then get plugged because for some reason you get the historical data that you didn't have before, is very useful. But with that in mind, I don't really see that we would be moving directly into a 95 to like a 90-some% cloud solution for doing the data analytics, given that we have found that it's not necessarily true that doing data analytics and big data on heterogeneous hardware architectures on commodity boxes is really proven to be the case as it was written in the big table paper. These are very, very, very custom bespoke hardware that do these jobs, and there's a real art to tuning the cluster and figuring out your preemption rules and the likes.
Yeah, I think if I could just kind of chime in, I think Mike is right about, especially in the government space, when we look at signals intelligence, real-time analytics that run on a streaming architecture, or perhaps what you can do with machine learning and data science in a constrained compute environment, for instance, at the front end, you're not going to have access to either large amounts of memory, large disk arrays, or even cloud. And so you may have to be on a special purpose compute platform that's optimized for those algorithms to run so that you're crunching the data as close to the point of collection before you're hauling it all the way back to the cloud. There's a lot of effort to try to reduce the amount of volume that's coming in, especially from expeditionary sensors. I mean, as capable as they are, you still might be constrained by the network pipes or the storage. And so the more analytics you can push out into that constrained environment on the front end, the better you can ensure the quality of the data, that there aren't bugs in the data, and that you're getting some insights from the data almost automatically before the analysts have to look at that. I know there's always a debate in the community. We want to see all the raw data. We want to make sure the algorithm's not filtering things that's not supposed to filter. And so there's always this trade-off. And then finally, having the data scientists have access to GPUs and other special parts of HPC hardware so that they can then optimize their algorithms is also an important part of what the data scientist does. Those aren't automatically provided just because you have a cloud. You have to make sure that they have access to those resources, that those resources are provisioned properly. And we're still sort of sorting out, how that works within our environment because, as Mike knows, when you move large amounts of data into that environment, you may have to refactor it, you may have to, mark it, tag it, and organize it differently. And so a lot of work goes into understanding how to optimize the use of that special purpose hardware in addition to just data management. Where is the data? Who has the copies, et cetera? So I think there's a lot that's involved in the discussion of cloud and data science, data analytics that spans multiple types of compute. And we need to talk about all of those, right? It's part of the entire ecosystem, and they each have their own kind of niche applications, but they're important as part of the ecosystem.
So just a real quick, interesting comment with what you just said. You know, we're all focused on multi-domain operations right now, right? Where we're taking land, air, sea, cyber, combining all that stuff together. Well, I would argue almost that within the IT realm, now as we're talking this big data problem and the cyber problem and integrating that in the operational environment, we've created multi-domain IT operations now, where we've got to figure out how to get the brain that's over on the table there, that's our brain trust for the machine learning and the algorithmic side of the house, and plug that guy in with the cybersecurity and the operational side of the IT infrastructure, and then figure out how to meld those together. I think that's an interesting problem set and an interesting challenge, because we all do kind of speak different languages, even within our own, IT structures, right? Sorry, just kind of interesting point of interjection there.
Indeed.
Thanks very much, guys. So kind of building on that question, but veering away from the cloud question and jumping more towards big data and analytics. All of the new progress from big data and analytics have allowed us to reimagine what questions we can ask of ourselves and ask of our data. So how do your organizations use the data that wasn't prevalent 5 years ago?
So I'll take this real quick. So I would say that for us, I think a lot of the data may have been prevalent, but we didn't have the speed and accuracy to crunch it that we do now. If any of you guys have ever heard Major General Yi talk, you may have heard his buffalo hunters story, right? Where, the buffalo hunters go out and they're culling the weak buffalo from the herd, right? And over time, the herd becomes stronger and stronger. And he uses this in a different sense, but I like it from a machine learning perspective, because, that's the goal of machine learning. That's what we're doing with these algorithms, is especially in the neural network frameworks, we're going and we're calling out the bad neurons, right? The bad pieces of the algorithms that are not being accurate compared to their other brethren. And we're making the algorithms smarter over time. And what we're doing now is we've gotten smarter, more intelligent about this approach, is we've gotten the algorithms to the point where they are now doing that themselves without manual intervention. I think that's a really cool space that we're really getting into, like, time now, that's going to facilitate even more the accuracy and efficacy of big data analytics. We probably had the data, it's just we didn't really know what to do with it and didn't have the capability or the compute power, maybe in some cases, to really get after stuff previously.
I'll talk to this a little bit. So I think that one of the things we've been able to do based upon exposing a broad amount of data sets to our analysts is that we've been able to zoom out the scope of the research that we've been doing. Aviation analysts now are starting to do just general transportation research analysis. So they were looking at the commerce flow across the United States based upon the national airspace system. And so now they're also looking at other modes of transportation, rail and vehicle flow throughout cities, and being able to holistically look at the transportation picture across the United States in a broad sense. So from aviation data sets, we've been able to bolt on highway system data through base safety messages of vehicles that have been built since 2012. So we can also look at the cybersecurity of those things and whether or not we can understand if we can digitally follow people throughout the national airspace, through that into the actual transportation network, and they get in their rental car and drive away and do other things. Those are the kinds of questions that we can start to answer based upon these data platforms and the aggregated data sets. So we have intelligence activities that are informed by transportation research. So there's a really broad amount of research that can be done in a holistic level for multiple mission sets. And so my work in transportation may inform other work to include commercial space operations.
So I'll just add two things to this conversation. So cybersecurity, cyber data was always part of NSA's mission, but what's changed over the last 5 years is both the volume of data that we get from our DoD sensors defending the network, but also the volume of attacks have increased at the same time, which means the speed of decision making has really tightened. And so we don't have that luxury of, picking up some malware samples, some intrusion, events, and then shipping them to the analyst who's working 8 to 5 Monday through Friday, right? We have gone to 24/7 cyber operations. We're in direct contact with security operations centers of both government and commercial networks because, again, we want to know, is this intrusion being targeted broadly, right? It's just malware that's just out there on the internet or is coming right after DoD or other government networks. So, that is really important information to determine how important it is to get more eyes and more analytics running against the information. So I'd say the speed of the cycle at which cyber defense is operating on is unprecedented, and that's probably changed from where we were 5 years ago when it was still fairly manual, still kind of an 8 to 5 type of thing. Now it's 24/7. It's how fast can you attribute, can you mitigate, and can you notify the victims, right? That all has to happen within 24 hours because every hour that goes by that you don't have a mitigation in place or you don't do victim notification, more data could be lost. And of course, we all know if the cyber intruder is effective at what they do, they will continue to expand into their network and then cover their tracks. So hours and minutes lost to the pursuit increases the difficulty of defending the system. So that's probably changed dramatically over the last 5 years. Certainly, we call it in the intelligence community space the new normal, right? This continued cyber intrusion, drumbeat that's occurring on a 24/7 basis. The second area I would also emphasize is the increase of the use of machine learning on textual analytics. So I think 5 years ago, it wasn't really believed that you could take, say, a 100-page document in a foreign language and summarize it in English in an abstract. Now machines can do that. In fact, they're doing it commercially. And so what used to take analysts time to both translate as well as to read and then summarize themselves, you can now ask a machine to do that triage for you. You don't even need keyword searching anymore. You can trust a machine learning algorithm to summarize large volumes of data and then just read the summaries and then determine which data you want to point the analyst to. And I think what surprised me over the last 5 years is this is not just an intelligence community problem. This is now something that the commercial world has invested in tremendously. I mean, it's kind of how your smart speakers work and how, a lot of the different summarization techniques, that feed you news information. All of this is going on behind the scenes, but there's an entire industry that's built up around summarizing textual information. That's something we can leverage in NSA, certainly, to help with the flood of data that our analysts are asked to look at in the 8 hours of their day, and hopefully to improve the quality of the intelligence that they report if those summaries are accurate enough to determine, yes, this is something that's not a priority to need to look at, but here's something that looks extremely valuable. So I think that's another area over the last 5 years I've seen tremendous growth of both the efficacy of the algorithms as well as the quality of the data that we're getting on the ability to use machine learning on summarizing text to perform topic modeling and even generate human-readable abstracts of voluminous information without human intervention.
So I'm going to pick on a topic that Dr. Renz brought up, and that is about the sensors, right? The amount of sensors that we have now has grown dramatically at exponential rate. And if we talk about just IoT in general, and not even including SCADA and IIoT, right, the industrial sensors there, the volume of data that comes into an analyst to consume is enormous to the point that you have alarm fatigue. And there's actually, lots of studies going on about will an analyst go into fatigue to the point of they're just going to ignore, they overload, right? And even if the sensors are providing actionable data, the analyst just can't take it in. So I think that is one of the huge challenges that has to occur. All the algorithms that are there to assist this analyst in making that decision, making the call, go, no go, whether I should shut down this circuit or not, or disable this device, is extremely critical. I think that's going to be the next 5 to 10 year issue. How do I assist this analyst in getting actionable information without overloading them?
I would certainly agree with Vincent. I think one of the things that we've noticed is that our government sponsors have difficulty scoring the casualty of outcomes based upon the data, such that we can really develop an algorithm that avoids those, and really putting regulation and policy in place and scoring that casualty of, not necessarily, the FAA has figured out what near midair collision needs to be held to, but after near midair collision, what is the next riskiest operation, and how do I weight that relative to a midair collision? Those kinds of questions are now having to be dealt with at the governmental level, and they've never been dealt with like this before. So these precursor events, how do you control for precursor event in the data now that we can discover them with the algorithms? That's one of the things that's really, really, really been difficult in order to get the outcome relative to the phenomenon, and then put that back into the data set and figure a way to codify that and then control for it in a regulatory fashion.
So you think that's an interesting point that you bring up. When you look at machine learning, you look at, going into things where we have not previously been able to explore, there's inherent risk, right? And risk is an important part of cyber, obviously. But when we look at these data sets and we look at these algorithms, we've got to have people. It's important to remember that people still have to be there, right? Because we're talking to cyber guy earlier today, and he was like, "Oh, you guys are doing all this stuff with machine learning. You're just trying to eliminate my job." And you can't do that, right? Because what happens if the data set becomes skewed? What happens if that algorithm ingests a glut of data that may or may not be accurate and nobody's watching it? And then, we're talking, we're operating some algorithms with a 99% accuracy level. What about that other 1%, right? So somebody has to be in the loop there to make that decision. Do I accept this risk? How do I mitigate that 1%? How do I help these algorithms, mature accurately? And I think that's an important piece to this conversation, both from a cloud perspective and a machine learning perspective.
Yeah, I would definitely follow up with that for real quick. So we try to hold those collisions that I was mentioning to no more than one collision per billion operations in the national airspace system, right? So we're talking 10 to the minus 9th probabilities. We really have to find a way to hold specific probabilistic outcome in a regulatory fashion. So I think the data has really exposed the governmental apparatus and the flaws in the regulation and or overlapping and conflicting regulation in operational agencies and departments.
Yeah, and it's important to realize also that 1 in X billion is still 662 people, right? Mm-hmm. So that's where having a human in the middle that actually has to accept that responsibility really comes into play.
That's exactly right.
So I'd like to use this as a great segue down to a question about machine learning and AI. So depending who you ask, artificial intelligence and all-encompassing machine learning will either save the world or destroy the world. And there's been a lot of emphasis this year on how to use machine learning to our benefit. So with that being said, is it going to live up to the hype?
I'll take that one. So I think that there's a lot of, you're right, there is a lot of hype about ML/AI. I think the biggest challenge in machine learning and artificial intelligence is informing our sponsors and customers as to what it truly is, so that we stop talking in circles about what ML and AI are. I found that most of the big data analytics problems that we try to tackle really are in and around IT integration problems that have never been solved, because those IT integration problems fail about 70% of the time. And the renaissance of DevOps and agile development have improved that somewhat, but I think that a lot of the IT integration problems that persist are, people put a lot of reliance on, like, maybe AI ML will help us like figure out truly what our data sets should look like, how they interrelate, and how we should be asking questions based upon the operation that we're doing. Sort of tell me the business intelligence I need to know in order to do the job better, even though we don't necessarily understand the outcome and we're not able to score the outcome relative to the data set over time. That's one of the big problems, is truly coming up with a training set for a machine learning algorithm, is that you have to have a serious discussion about what you're doing and your operation and how that, what the measures of performance are and what success looks like. And those discussions are very hard, and they become exceedingly organizationally political. And there's a lot of fear when you do those sorts of things on a governmental level.
Yeah, I think AI and machine learning, as long as they're tightly coupled to the human and confidence levels and other, various assumptions related to risk, will actually be net beneficial to improving analyst outcomes. But the key part is the algorithms themselves are not an end in and of themselves. You need somebody to curate them behind the scenes with training data sets, right, as Mike was saying. But most importantly, you need to have people who understand when to apply which algorithm to which data set. As an example, I mentioned some of the work we're doing on textual analysis with machine learning. What we find is, the machine learning algorithms, you need 3 different algorithms for 3 different types of data. Short sentences like text messages, machine learners that work against that do not work against a textbook or a magazine article, right, or a long email. And so we're still in that phase where there's a lot of tailoring that needs to take place of the training data sets, the algorithms, and the scoring, so that the analysts understand how to apply these tools. One of the things that we're doing within NSA is just teaching the intelligence analysts how to interact with data scientists and what the vocabulary of data science is, so they can ask intelligent questions of the data scientists and ultimately of the data. And so if we can understand how that workflow operates, AI and ML will never replace the human. They'll just make the human better at what they do. And all of this work is continuous. Just because you have one algorithm that starts to work on a certain data set for 6 months doesn't mean it's going to work for the next 6 years, because your target will evolve, your data will change, perhaps even the questions you're asking of the data that initiated your first 6 months are not the same questions you're going to ask in 12 months or 18 months. The questions change, so the algorithms have to adapt to that. So what we see is actually perhaps the future analyst, not the data scientist, but the analyst who's looking at the output of these algorithms, perhaps has their data set and bangs it against 3 or 4 different machine learning algorithms, and then makes a judgment based on confidence levels and other scoring factors as to which avenue to pursue. So we still see very much a human in the decision cycle, in that decision loop, and then the data scientist behind the scenes with that creative energy, developing those algorithms, continuing to learn what analytic questions need to be asked of the data, and refining the approach. So this is not a kind of a one and done. This is going to be a continuous workflow that'll be with us, we hope, for several decades.
I'd like to follow up. So this really reminds me of some things that come to mind, in that we really need to be mindful of how we apply algorithms in general. So bear with me for a moment. This makes me think about that movie Idiocracy, where the character goes to buy a hamburger for their child and doesn't have any money. So the machine's like, "You're a bad mother. We're going to take away your child." So there's definitely great power in using machine learning and doing these artificial intelligence activities, but really understanding the data set and the appropriateness of applying an analytic to a specific data set and the variances under that data set, and whether or not the intended purpose and use of that data set should inform that algorithm has really become an emergent problem. By opening data sets to every analyst that has access to the computer and understands Linux a bit, we are making many statisticians from various backgrounds that may or may not have understood the statistics in the first place. And I feel that one of my fundamental challenges with working with governmental sponsors is that I'm trying to get people to stop talking just about averages and start talking about confidence bounds around the result. such that we can have a meaningful discussion about the variance of the analytic result and whether or not it's appropriate to make an operational decision on the analytic just quite yet. Yes, I know it's called machine learning and AI, but is it really good enough to be able to operationalize the solution?
So, yeah, is it going to live up to the hype? In my world, it already has, just because of what we're able to do for our customers, for the DoD, and for the commercial world, right? But I'm a tactical guy. So when I go out and I go visit Army posts, I go talk to the tactical units, and I kind of give them like a 100,000 foot view of this stuff. And their questions usually revolve around two things, because I like to go talk to like infantry units and stuff, and that's jobs. Is it going to affect our jobs at the end of the day? And are we going to make Skynet? And, we're not at that level yet, right? So when we talk AI, what we're really talking about right now is deep machine learning. So there's fundamental differences in all these different levels, but we're not to the ability yet where we're going to make Skynet, unless I'm Skynet and it already exists, right? So there's not really AI, but machine learning, absolutely, 100% living up to the hype every day. But I think we need to reframe that question, right? So it's not that it's going to live up to the hype. It's what is it going to do for us, right? So right now, with what we have, we're able to make the user experience better. We're able to make these data sets visible and accessible to an operator that may or may not have Security Plus down at the tactical edge, right? That's really powerful. To make that understandable to somebody who's got a basic level of training knowledge, that's really cool. We're able to give our analysts more focus, which gives them more time to get after the more difficult and dangerous problem sets, right? We're able to reduce operational risk within environments ranging from corporate and otherwise, and give visibility and tangibility to that risk in an automated fashion. And we're able, using all this data in combination with data points from other fields, not just cyber-related data, but operational data, to provide commanders situational understanding of the battle space in a way that we never could before, to where they're able to make better informed decisions using these data sets. But what does it really look like, right? We're talking algorithms, we're talking, data sets, we're talking data lakes, but to somebody who's at the operational and tactical level, they're never going to see that. What are they going to see, right? They're going to see a screen. They're going to see a product. So at the end of the day, all that we're trying to say is that these capabilities are coming. They're going to get in the hands of the warfighter. We're going to provide them a platform that's usable and understandable in ways that they never could have imagined and that we never could have imagined up until a couple of years ago. So is it living up to the hype? Yes. Are we living the dream every day? Absolutely. And Skynet, we'll see.
So I'd like to call it assistive technology, right? It's really not going to replace what we have in front of us for the near future. And the reason for that is, again, the human element. And I'm going to use, a use case where BMW has claimed that they can stop their cars automatically. And interesting enough, I went on a test drive with my wife. And we found out that technology is not real perfect because it decided to plow a couple cars in front of us. So again, is it a work in progress? Yes. Does it assist our personnel in the way that they do things? Absolutely, right? We are down on manning, right? Personnel. To have that assistive technology sitting there being the 20 people that are not in the room is fabulous. We're experiencing that. Is it perfect? No. But is it getting better? Absolutely, every single day. And I think the part that we become even more credible over time as we refine the algorithms, we get more processing power, and more importantly, we look at the problem sets we're trying to solve and scale them back, right? If you look at the autonomous driving issue altogether, we're marvelous human beings, right? Because we can discern that's a red light, no matter where it is. For a car to determine that is almost impossible. What if you have a red car in front of you? Right? All the other factors that we have to now train a computer to think like us is so difficult. If we were there, we would have robots servicing us all the time, right? They can't even walk upstairs, right? These are very simple things that we are allowed to do. So it's a work in progress. We'll give it some time, and it will get there, but we need that time.
I'd like to reinforce Vincent's point. So we use a lot of ML to go ahead and fix. So given that we have an aggregated sensor suite across the United States for, like, say, radars, we use ML to tell Raytheon to go out and fix the registration on their radar, because we found out one of their sensors may have a range bearing or azimuth problem in that the radar has shifted based upon the Earth moving a little bit, or this stand of trees that needs to be cut down type thing. So really what we're doing is we're looking at being able to identify an erroneous sensor issue that's very, very indiscernible to the casual analyst, and then fix that so that as time goes on, the ability for us to inform the operation based upon the sensor suite improves based upon us being able to fix the sensors that we don't necessarily have dominion over. So those are the types of applications that ordinarily you wouldn't think, like, hey, ML, but yeah, really, we've been able to go out and say, well, these are the reliable sensors, and this is how you can improve it, and it's like, 1.25 degrees off in this direction. Those are very, very interesting things to do with algorithms like this that were never intended for OEMs.
Yeah, so I don't know if any of you guys are playing conference bingo, right? But we've hit on what have traditionally been probably every single buzzword in the IT conference world. The cool thing with this that we're talking about, though, is that we're talking about this from an operational capability. 2 years ago, we were still joking about how these were just words on a bingo card. And now we're talking about putting this stuff in the hands of a warfighter. That's awesome. Yeah, that's all.
Yeah, and I think Mike, your point about having machine learning or AI, looking at the edge cases or the anomalies that go undetected, that's one of the applications that we're using machine learning for, is to look at the space that the analysts don't normally look at, not because it's not valuable, it just doesn't produce value that often. And so the analysts want to park on the intelligence source that gives them the most value, but there's other sources out there that occasionally yield great insight, but nobody's able to look at them or spend their time querying them. So if you can have a machine learning algorithm that's kind of covering the entire space and then recommending to the analyst, hey, remember that sensor over there? Normally doesn't collect any intelligence. Something has happened. Why don't you take a look at it? And it just filters out the data that the analyst needs to see. And that has actually been kind of a force multiplier. So a way to deal with complexity and scale, because our people are not growing in their capacity, is to use machine learning to deal with that kind of breadth of problem and have machine learning work from the outside in, right? Have it work on those areas that are underexplored first, demonstrate value there, as they then build the trust of the analyst to then work at the high value level. And so we're actually doing some of that at NSA Hawaii by working on kind of those low probability data sets, but having the machine learner find actual value that was missed by the analyst, or would have been intractable to have an analyst plow through all that data to find the one or two things that were reportable.
Thank you, guys. So we've seen a lot of success with big data, analytics, processing, machine learning, AI, and I'd like to jump more towards the challenges question. So between all of the new capabilities and more data, there's a lot of good insights coming out of that and problems we're trying to solve, but it doesn't always turn into a better decision, a faster decision, a smarter decision. So with that in light, what are the biggest challenges you guys have facing the democratization of using data for decision making?
I'll jump on that. Years ago, I gave a presentation on going on a data diet, and a lot of people looked at me and said, "Are you kidding me? Data's growing every day." I said, data that's useful is not growing every day. You're collecting a lot of information, holding on to a lot of information you don't need to keep. You're creating vulnerabilities by doing that. can't tell you how many pictures of your dog you have, right? I mean, just a case point. But if you look at documents, policies, procedures, a variety of things that we keep, there are enormous amounts of versions there. And because of that, you don't know what truth is. You don't know what the real version, what the released copy was. And because of that, you create your own problems there by having stale data. And you're making decisions on stale data. That data purge that needs to occur has to be by policy, by whatever metrics you want to envelop. And you can put those data sets somewhere else for a while and say, okay, if I ever have to visit them, I can. But by having that stale data around, you actually muddy the waters.
I'd like to counterpoint Vincent a little bit. So I never met a data set I didn't like. That's one of our biggest problems. The other issue that was really burning a hole in the analytic community is that as these data sets get used, we make recommendations based on those data sets. Sometimes those data sets are exceedingly important in that we are making, we were discussing safety recommendations for 600 and some people that are floating through the air in those metal tubes. The pedigree of the base raw data and the analytic pipeline that brought that answer needs to be curated until the answer itself and the operational solution is obsolete. From that, this year, we are taking a 2.9 petabyte data set, and we will exceed 10 petabytes by the end of this fiscal year. So every analytic solution that the government implements needs to be corroborated back to the raw data, including the tooling that generated it. So version control and the ability to deal with errors and how that works and adjudicating errors and then promoting that back to your sponsor and saying, we think we found something here. We might need to adjust that operational solution is a big deal. It's as big deal as big data. And being able to recreate those data sets, I would agree there's a lot of intermediate staging table and second and third order analytic that could be removed and the base code set then be stored in order to regenerate that analytic result. But really the accounting of taking raw data and carrying it through to operational solution is causing storage to go exponential. And that is a concern for us.
So, this is an interesting process, right? I think when we're looking at, how we're actually getting around these data sets and giving, we're almost like giving the data a vote, right? And that's scary from a risk perspective. So how do we get around that, How do we get around the area where both the data and the algorithms and the humans and our enemies are all getting a vote? So from a machine learning perspective, we're doing ensembling, which one is none, right? Everybody's heard that expression before, I'm pretty sure. So one algorithm is not the best algorithms. Two algorithms is maybe an okay algorithm, and three is probably the best solution out of that, but we don't want to get too complicated. So we're really at a constant balancing act where we want to be in a constant balancing act. I think this is an environment where if we start to feel comfortable, we've probably failed. So if we don't feel like we're tilting constantly forward, both from a capabilities perspective and from a risk perspective, and just from an overall comfort perspective, I think we're going down the wrong pathway.
I'm reminded of a quote from John Naisbitt, who is the renowned futurist, and he said, "We're drowning in data but starving for knowledge." And he said that in 1982. And so this has been a problem for many, many decades, right? This is not a new problem. I think what's potentially new here is, and the question was about decision making, when you get to the executive level, the executives want to understand what analysis went into the data, but they also want to understand the boundary conditions. And so whether, we're now presenting decisions to our senior executives with a formal risk assessment that comes along with it, and we're exploring the science of decision making, multi-criteria decision analysis, which is actually a data science application of executive decision making. And so how do you weight, whether it's different algorithms or different analytic outcomes, how do you provide weighting factors so that the executives can actually make an informed decision? And perhaps this is somewhat quantitative as opposed to subjective, because at the end of the day, the executives can't consume all of that data either. They have to trust the analytic judgment of an analyst who's run an algorithm. How do they determine those right and left limits if we're going to make a decision? And so I think, believe it or not, some of the answers are to look at some of these new models for decision making that involve quantitative factors like formal risk assessments and multi-criteria decision analysis. So that's another place where data science could potentially play a new role in helping us better understand how to weight inputs and outputs from these various sources that go into decision making.
I think we touched on a lot of these next set of questions before, but I'm going to circle back and we can dive a little bit deeper on them. The data sets that we have are projected to continue growing, potentially 5x, 10x, and even some exponentially, as Mike mentioned, going from 2 petabytes to 10 this year. So with that specific problem, how are your organizations approaching that influx of data? Is it a variety of paring it down before you input it? Is it something where you think you need to scale? Is the storage market going to keep up with us?
Yeah, so I'll take a little stab at that one. So the first is, it's not about volume as much as it's about having the right data that you're storing. And so there's a lot of work that, and I mentioned this at the beginning of the panel discussion, we can do at the front end to make sure the data that we're actually storing has sufficient quality and fidelity and intelligence value, right? So the more we can pre-filter the data without losing fidelity, without losing, the edge cases, the anomalies that still might, be unpredictable patterns that we need data scientists to look at, I think the better we can manage that storage problem. And the other thing that we're doing is, there's a lot of, video out there. High-def video is a big part of military operations today. So imagine that we intercept, an HD video of a drone, of adversary's drone going over some area for many hours. There's a lot of data that we would store if we just stored that entire video. But perhaps what we want to do is just get keyframes, do some object recognition on that video, and store the key parts of the video. So it's not necessary to store, the full 8 or 12 hours of intercept, but perhaps the key frames and some of the key areas where there's change detection, and do some object recognition on that so it's easily searchable. So we're looking at ways to make sure that if we're storing raw data, it comes along with the metadata that tells us a little bit more about what's in it. And then, we still have the problem of encryption, right? A big part of what the agency does is cryptanalysis, and unfortunately, if someone's implementing their cryptography properly, that does not compress very well. And so a lot of our storage has to be devoted to storing off, large samples of traffic that's encrypted, so our cryptanalysis can can figure out whether or not they can, glean some intelligence from what's been intercepted. So I would much rather see things that are, in plain text and raw, summarized, do some recognition on it, do some compression on that, and save our storage space for the real nation-state hard problems, which our cryptanalysts have to deal with every day. I mean, that is going to be all-consuming if you can consider the volume and magnitude of that problem. And so the better we can get at compressing the information down to what's in it and not treat it in its raw form, I think the better we can manage that storage problem.
So I'd like to follow up on that. So I'm sure you have all heard that data is the new oil. Raw data is not replaceable. You can look at you can approach it by looking at snapshotting for temporal systems and storing the differences of those temporal systems in order to minimize the storage payload. For derivative analytic, there's a different calculus that has to go into play, which is the carrying cost of the storage of the derivative analytic as opposed to the recompute cost. And if those types of business decisions are approached in an analytic and rational fashion, then we'll be much better off rather than I don't have time, or an analyst to say, I don't have time to rerun the DAG, so I'm going to store all the stage because it's not my problem, and I don't buy the infrastructure purchases, so I don't need to worry about that, and I'll let the C-suite handle that problem. So there is a bit of due diligence that needs to be done at the analytic level. With that being said, I don't expect that the data is ever going to plateau. So the more raw data we have, the better insights we can draw, the more refined we can bring our analytics to an operational end such that it can create value, true value. There are many big data stores that have been created sort of as a field of dreams that have never truly reached any sort of operational result and are essentially sandboxes for nerds and mathematicians. So there really needs to be a business case against doing data analytics and whether or not you need to be in the business of storing large amounts of operational organizational data.
So, from a data glut perspective, we like data. Data makes what we're doing smarter, particularly in the spaces where it's coming from, which is from the user base, and that's where the data points are especially pertinent to getting after some of the cybersecurity problems that we're solving. But, in the space, we typically talk about the data scientists, right? We talk about the guys that are developing the algorithms, that are advancing the state of machine learning, that are going after these problem sets. But I would argue that where we are right now, as we start to gather more and more data, we run into these storage problems, we run into budgetary limitations, bringing in somebody, a data engineer is almost just as important. So, now we need to have the conversations about, how do we store this? How do we store this data? Do we store this data? What's our retention policy? And that's where somebody who's a subject matter expert about data use and your environment, because you can't have one without the other when we're talking about this stuff, really comes into play. And I think that's something that, from a human resources and talent management perspective, we haven't even started to scratch the surface of addressing.
So I think one of the biggest things that the storage field has forgotten about is compression. And the reason they've forgotten about it because disk space is so cheap, right? And so if we go back to the philosophy that we tokenize and we store it as tokens, we can actually maximize our storage very, very rapidly. In the case of video and encryption, I totally get it. But as being one of the math geeks up here, they're probably going to be prime numbers. So we know what those prime numbers are. So it's not out of reach for us to store them as a tokenized prime number. So if we look at it that way of saying it makes more sense for you to compress for us with that expanded storage, then you'll have, hopefully, right, just as we have our cloud environment, unlimited storage based upon the fact that we improve our tokenization, our compression mechanisms.
The risk with that is that you start removing some of the access for some of the analysts by having binary compress object. And we've seen some trouble with that. But there are compression methods that get to part of that problem in that we need to be able to map and reduce as quickly as possible. So there's Avro and Parquet, which are these binary yet parsable and compressible objects that have self-describing schema, and it's very handy for us to write that into our analytic tooling. The issue I've seen is that as you institute a format change in your data structure, so does all your code base. So that's a very expensive move to make. It's probably a move you should make earlier than later.
Right, and I totally agree with you, but I think it should be hardware-based, and that way we get rid of having to write code over and over again. So if we make use of the fact that we have FPGAs and we can program up ahead, boom, we're hardware-assisted and not worry about having a software engine sitting there.
Yeah, and I think, Chuck, you talked about retention policy, and that's something as we moved to the cloud, we had to be very careful about, right? We have very specific retention policies applied to signals intelligence. And if the data is not touched, hasn't been looked at in 5 years, it's gone, right? We have to purge that data. And so you can't have an effective policy for purging unless you've tagged your data and you're tracking who's looking at it and who has authorization to retain it. And so part of our smart data tagging initiative is to make sure that every piece of data is authorized to be there for the period of time that we have it. And if it's not, it's fairly easy to wipe it out, right? So that is actually something that the cloud does enable, in addition to the security features, is the effective implementation of a data retention policy. And that's something that, Congress and, the courts hold us to make sure that we're abiding by the laws that govern how we conduct our signals intelligence mission.
Yeah, I believe that I'm more of a data historian in that I definitely still read the books about how the Roman Empire fell because that data is still relevant to me. Honestly, if you approach the world from a historical perspective, the data sets themselves will gain value and use over time regardless of the timeliness of it. And I'm sure that there is some point in time, like, we declassify information after, 30 years? So there is a point where it loses relevance in some regard. But I do believe that it informs our activities as humans on this earth, and that if we have a way of storing it and it can be cheap, then why not?
So, from an operational perspective, real quick, I know we're running short on time, but if you look at where we are from a security perspective in the DoD, we've actually reduced our ability to retain the original data with the way that we have implemented kind of the joint, the JIE and JRSS. Especially, I'll give a National Guard perspective. We don't have full packet capture down at our lowest levels anymore. All that portion is retained up high. So if something happens, there's a risk now, and there's a balance between the resourcing and the time and the personnel constraints versus having that data to where you can actually do investigations. So, there's some different operational perspectives in here, too, that we can't just, high level it. We've got to really look at what the impact is of where we're storing the data and where we're collecting it and where we're letting that aggregate.
So I'm going to add to that because I was on the GRSS team for PACOM, and I advocated for hybrid storage of your packet captures at the location for that very reason, was exactly what you're saying. I need actionable information. I need to delve through it. And it doesn't matter if it's 30 days old or 60 days old. The incident occurred when the incident occurred. So that's the difficulty with policy, especially when you talk about cyber. How long do I retain? Well, I don't know when the intrusion occurred. So if I artificially cut it off after 6 months, I have no data. So that's the difficult quandary that we're faced when, especially we talk about the cyber realm. I agree with you. We need to say by policy in certain areas, if it's a very specific mission, you need to retain this for whatever period of time, because you are going to be that archaeological historian going after that data and said, okay, I know exactly what happened at this time. And we're getting a replay of the same attack. And if we didn't have that information, we wouldn't know how to defend against it.
Unfortunately, Murphy's Law still applies, and I don't know the data that I need until I know I need it.
Right.
And the enemy always gets a vote.
Yeah. Right.
So I'd like to take a moment. We have just a couple minutes left to kind of recap all the salient points that have been made today. I've been taking notes. I think I'm up to 5 or 6 pages during the conversation, and I'd just like to hit a couple of high points that I think are really relevant as takeaway points from this. So in context of how data and cloud and analytics are changing our world, there is a big need to take what we've done and go further. So that can be recruiting data scientists into our organizations and really giving everybody in the organization an opportunity to embrace the technology that's been presented. It also gave us a chance to rethink security for everything going forward, not just about what we've learned from past problems, but everything in the future from cloud architecture. In addition to that, cloud has a lot of benefits I think we've seen before, but just from a cost savings perspective, over $100 million for Chuck and his organization in the past couple of years. And one of the really key points of that is making sure that still benefits us. So taking that data protection strategy and ensuring it still works for us in the cloud. Data and all these analytics have become a multi-domain problem. So in order to solve this, we have to draw from each of those expertises and be able to pull those key components together. It's not just the data itself, but the data in its own context. From a scope and scale perspective, data has given us the opportunity to zoom out and look at bigger problems and bigger picture problems we've never been able to see before. Mike and his work has been able to take what would have been a one view of safety data and be able to apply that to other domains as well. With the benefits of more data, we have just as many challenges in the future, whether that's more data for our adversaries to use to attack us. The speed of the attacks comes with more opportunity for the same use of infrastructure, but for the worst, and we need to be able to anticipate that and address it appropriately. From a machine learning and AI perspective, there's a lot of good, but we need to be able to look down the road and see how we can handle it. And I think we've all agreed it's not going to replace any humans, certainly not in 2018. But going forward, our goals are going to be how do we use that to our advantage and really augment what our workforces and our skilled data scientists, technicians, engineers, whomever needs that data, help them do their job better, faster, and more effectively. And I think finally, using that machine learning to draw answers out of data sets and problems that we couldn't normally see, but gives us an opportunity to benefit how we can attack those problems. And I think my final thought from all of this has been, we're just at the beginning. All of these problems are really only starting to come to light, and the opportunities present themselves. I think in the next 5 years, we'll see an entire new series of professions born out of this set of technologies, and much like we saw 5 years ago and the 5 years before that, but it's only going to accelerate. So all of the data and its benefits will come with new opportunities for those same folks that want to stay on top of it. So I'd like to say thanks to all the panelists. I really appreciate everyone's participation and insights, and thanks to you all for attending.